In this lesson, we'll take a look at how we can utilize the Contour Shader Layer Thinner node. Alright, so this particular contour shader is one that will allow us to change the thickness of the lines based on how many surfaces that line will have to pass through in order to reach the camera. Alright, so this will make just a little bit more sense here in just a moment once we actually see what this shader does. Now before we actually plug in this particular shader, there are a couple of things you'll need to make sure that you do. First, you'll need to make sure that you have the contour rendering enabled, and you'll also need to make sure that you have the contrast function levels and the store function both plugged in to your custom shaders. Otherwise, what we're about to do won't work. So once you have these things activated, we can now plug in the Layer Thinner node. Alright, so let's come in and we'll drop in Layer Thinner. There we go, and let's take a look inside the material that we want. Go ahead and expose the shading group for this. There we go. And let's take this contour shader and drop it right in. Now, with this particular node, there is actually very few attributes to have to adjust. The first is the main line color. Now let's go ahead and set this to something bright so we can actually see it. The main attribute, which controls the width, is the overall thickness of the line at its absolute thickest. Below this, we have the factor. Now this is controlling how thin the line will become at every surface that it has to pass through. So for every surface that it has to pass through, the line will get this much thinner. So let's go ahead and just take a quick render at what we have. So initially, once we render, you can see that we do have these lines, but they are at every triangle of this particular polygon. So we do need to make sure that we go back to the hypershade, take a look inside the utilities, and make sure that our contrast function levels, that we have the difference index turned off. And there we go. That way we won't get any sort of intersections around the actual triangles. Now to increase the sensitivity to areas like this, we'll just need to come back to the normal delta and make sure that that's just a little bit less than 90 degrees. Because right now this angle is right at 90 degrees, so it may not be enough to pick it up. And there we go. Alright, so in order to see this actually take place, let's just first go back to the materials. Let's go over to the Lambert itself, and let's begin to increase its transparency. That way we can begin to see some of these contour lines come through. Now, whenever we first render, we actually won't see any sort of a result. You can see that we do have transparency in these areas, but we actually don't have any contour lines that show up. So what we need to do, if you have any sort of a transparent surface that you do want these contour lines to be able to see through, what we will have to do is, again, go back to our contour contrast node and increase the maximum level of ray tracing rays, or of ray interactions that can take place. Right now it's just set to 1, so once the ray hits a single surface, it reports back. In order for the ray to be able to reach through these multiple surfaces and see these actual areas back here, let's just start to increase this max level. We'll start with something like 3 for 3 ray interactions. And there we go. Now we can actually start to see some sort of a result. So you'll notice, again, these areas of the lines that are most directly visible to the camera, that don't have to pass through any surfaces to be visible, are very thick. However, something like this line right here that actually has to pass through a couple of different faces in order to be seen is a little bit thinner. And this area right back in here that actually has to pass through multiple faces in order to be seen is now fairly thin. So let's take a look back at the actual contour shader itself. Again, we do have control over the beginning thickness of this line. So we'll start with something like this. And again, for every surface that it has to pass through, it will now decrease by about half of its original size. And that's exactly what we get. Now, if we wanted this actual result to be reversed, where we maybe start with a thinner line, and then this line gets progressively thicker as it passes through more surfaces, we could actually control that. So if we were to start with a fairly small line width, now right now with the factor set to anything lower than 1, that means the width will be decreased as it passes through surfaces. If we were to increase this factor to something higher than 1, let's say something like 2, that means now the factor will increase, or increase the line width based on the number of interactions. So this is what we had before. We can save this for comparison. And now we get an effect that is completely reversed. So now we start with a thin line, and the lines get progressively thicker as we move through more surfaces. Now you will notice that there's actually an area right back in here where we don't have any contour lines, where we actually should. So if you run into a situation like this, all we'll have to do is go back and start to increase the number of ray interactions. Right now we have it set to a maximum of 3, so let's bump this up to a maximum of 4, and re-render. And there we go. Again, as you can see, now these areas that have to pass through the most number of faces in order to be visible by the camera now have the thickest lines. So that's a look at how we can utilize this actual contour shader that will let us change the line thickness based on how many surfaces the ray will have to pass through in order to make that contour line visible to the camera.